Welcome again to another episode of Astrophotography 101. In this episode, we're going to be discussing filters, and filter is a very technical part of your camera. So we're going to be doing exactly like what we did when it came to the guiding episode. We're going to answer a few questions and then giving at the end a demonstration and also the available markets and the available options in the market. So starting by what is filters, why we need filters, and how to use filters and how to choose them. So what is filters? First, filters is basically something to remove a part of what you are doing in order for you to have the other part of it. Same like when you are adding a filter to the sound to filter some kind of sound. So here we are filtering some kind of light. And since the light is an electromagnetic wave, or part of the visible light is part of the electromagnetic wave, so we are filtering partial of these lights or partial of these waves in order for us to get a better image. So why we need the filters? Sky have light pollution since we are living in a modern age and we have artificial lights. So this affects your image and make the sky dome looks lighter, and if you are taking a long exposure, that this will cause a problem for you, that the image will be very bright and you will not be able to see what you are photographing in the background of that light. So in order for you to get a better image, you need to filter some of that light. Some of that light can be light pollution, some of this light can be the light of the moon, some of this light can be even an infrared light that you cannot see, or an ultraviolet light that you cannot see, but your camera sensor is not same like your eyes. It can see things that your eyes cannot see. Therefore, you might need an infrared cut filter or an IR cut filter, or one filter that can do both the jobs and only allowing the visible light. So when we need to use filter and how we use them based on what? First, you need to state that we are photographing either nebulae or we are photographing galaxies most of the time. I'm not talking here about planets, but I'm talking mainly about most of the people photograph. So for nebulae, without going into a lot of technical details about what is the emission of each nebulae and what is hydrogen alpha and oxygen 3 now, the general rule is when you are capturing images of nebulae, you need to capture with a narrowband filters, and when you are capturing galaxies, you need to use the full spectrum of light or the wide band of the spectrum of light. So it makes sense that with galaxies you don't need to use any filter, correct? That's correct to a certain extent. If your camera has an IR cut filter or IR UV cut filter, then you don't need any filter, you can capture them with your camera directly. However, if your camera doesn't have an IR/UV cut filter, then you need to buy a specific filter, something like this filter, which is an IR/UV cut filter, this filter, and you will see that when I'm turning it, it turns to the shade of purple or a little bit greenish. This is an IR cut filter, and basically it cuts whatever is below the visible light of the UV filter, of the visible light which is UV, and above the visible light which is infrared lights. So how to know if your camera has them or no? Simply go to the specification sheet of your camera on the website that is advertising it, and it will say, for example, the 533 doesn't have that, so my telescope requires this kind of filter in order for it to not have a problem. What kind of problem? We can talk about that all day long, because it depends on how your lenses work together in the telescope, if they are able to focus the infrared light within your image, or they focus them in a different focal point. But the general rule is, if your camera doesn't have an IR UV cut filter, buy a UV IR cap filter, install it in a drawer for the camera, which we will be showing later, and then fix it within your light pass of the telescope, and you will be good to go. However, for nebulae are two kinds, and they either have an emission nebulae and either a reflective nebulae. The simple idea here is that a reflective nebula is basically a cloud of gas that reflects the light of the stars that it's surrounding. So the light actually is a broadband light. But an emission nebula is a nebula that emits its own light based on the hydrogen inside it or the oxygen inside it that is hot enough to emit its own light. And to understand that, I will be demonstrating it in the technical part of this video on the laptop and how to understand the wavelength of each light. However, there is more important thing to discuss about the different type of filters, and it is filters that made for monochrome camera and filters that are made for a color camera. The monochrome camera, since it's only capturing monochrome image, that it needs a red filter, a blue filter, a green filter, that you put it in a filter wheel, and then you capture based on those colors, based on those filters, those colors. However, if you are capturing an emission nebula and you need to capture an emission nebula that have mostly hydrogen alpha or oxygen 3 or sulfur 2 or hydrogen beta, then you need a filter for each one of them, and this will extend the period of time that you are capturing by much. When it comes to color camera, which is, I'm going to be focusing on this one since it's the beginner choice. And to be honest, it's the intermediate choice, and even some experts use this one because they are fed up from the amount of time they are investing in capturing all of the spectrum of light just for one image. So the color camera filters is basically two types of filters. As the first filter we already discussed, the IR/UV light filter, cut filter. The second filter is a narrow dual band filter, and this filter becomes very important for this camera since obviously the camera can see all of the spectrums of light, and now your emission nebula is only emitting hydrogen alpha or oxygen 3 or sulfur 2 or oxygen or hydrogen beta. However, we'll be focusing only on hydrogen alpha and oxygen 3 because they represent above 97% of most of the universe. So anything that is emitting light will be most probably within these two. So by definition, you can buy a filter that only allow these two spectrum of light, since each material of those that we spoke about, hydrogen alpha emits a specific wavelength, which is basically 565 nanometer of wavelength, and oxygen 3 emits a specific wavelength, which is I believe 450, if I'm not mistaken. So, or 500, I'm sorry, 500. So if you have a filter that can only pass these two wavelengths and ignore the rest of them, then you will be as good as you don't have a light pollution because you are ignoring all the light pollution, since all of the light pollution comes from pulps, and these pulps are either halogen or mercury, and those materials emit a specific also wavelengths. So if you are ignoring those wavelengths, then it's almost like you don't have light pollution. Almost, I'm saying almost because there is another factors, but it's good enough. And once you buy these filters, you can capture a beautiful images, sharp and crisp images of nebulae, emission nebulae specifically, like something like the Horsehead Nebulae or a little bit of the Orion Nebulae, or something like the Rosette Nebulae, the Horsehead Nebulae, the Heart Nebulae, the American Nebulae, and some more. However, this is one type of the nebulae. The rest of the nebulae, it's called a reflective nebulae, because the reflective nebulae reflects the light that the star around it is emitting, and this is a broadband wavelength. But the emission nebulae is a nebulae that emits its own light based on the material that it's made of, which is mostly hydrogen alpha and oxygen 3. The material itself, or the cloud itself, is hot enough to emit that kind of light spectrum. Okay, so now what is the available options in the market and how to choose from them? The basic idea will be this: if you are a beginner, you have you have a colored camera that you want to buy filters for, and you want something like the 533. If your camera has infrared UV cut filter, then only buy a dual narrowband filter with 7 nanometer width of that filter. An example for that will be the SV Boni SV220 or the Optilong L Extreme or L Pro. These last two are on the expensive side. So the budget option will be the SV220. You will be good to go there, and you can capture all the emission nebulae in the sky with the amazing details, and you don't need a lot of exposure time, which will help you also with guiding. If you are looking for photographing galaxies, your galaxies, since you are a beginner again and you have a smaller telescope, so your galaxies will look just a bit smaller or a lot smaller. So buy an IR/UV cut filter and photograph with that, and you'll be good to go. However, there is some companies like SV Boni, they provide some filters for specifically made for galaxies, something like the SV240 and the SV260. I would recommend the SV240 above the SV260 above the SV240, since the SV240 does not block infrared or light. And if your camera doesn't have that filter, then you will have a problem with halos around stars, as you will see in the episode that we will have on the ASI Air and capturing all the night. So the SV260 will be a much better choice. Or at least you can buy any CLS filter. It's a light pollution filter from SV Boni, from Optilong, from from Ascar, if you have enough money to buy that, and you will be good there. And please buy the 2-inch filter and buy a drawer for it that you can install, a drawer like this one, and you install inside it this shelf, which you can actually install the filter in it. The filter has a thread and this one, and you just screw it inside and then insert it like this inside, and this will make your life much easier if you have 2-3 filters and you have a few drawers coming with it. So you can install it this and remove it quickly and very easily. These are the options in the market for these filters, and as I explained, how to find the right filter for you based on what you are photographing. I will be showing now a technical part. I left this part till the end because not everyone is interested in technicalities. But if you are like me and you think technicalities make things comes alive, then I will highly advise you to watch this part, even if you are not a technical guy. This part will make you understand exactly how wavelengths work within the light spectrum, and trust me, in the future you will not need any review of any filter. You will be able to choose the right filter for your need. I hope that helps. We will jump to the computer and I will come back. Now for the technical part. All the wavelengths around us is electromagnetic waves, and the light is actually part of the electromagnetic wave, which fits here a little bit between the UV light and the infrared light. So above it there is the infrared, and below it is the UV in terms of the wavelength. However, in terms of frequency, it's the opposite. To understand this part, imagine the light is similar to sound, and I will make a small demonstration here to understand the difference between frequency and wavelength. If I have a sound that it ticks like this, tick, 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 and another sound that it ticks like tick, 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 tick. The wave length, or the frequency the first one is happening is less than the frequency of the second one is happening. But similarly, if you're looking to that graph, the first sound was here and the second sound is here because the second sound was more frequent than the first sound. But that makes the distance between the waves are much shorter in the high frequency rather than the low frequency. So this represent here the blue light, and on the right here it represent the infrared, the red light. So anything above that will be infrared because it's under the red, which is under the frequency of the red. And anything that here is high frequency above that will be called ultraviolet, which means above the violet color, right? So to put that in perspective, when you are buying a filter, as an example, like this one, the SV220, that this is the wavelength here of the hydrogen alpha, and this one is the oxygen 3. So this is closer to the red and this is closer to the blue. So anything that here is, this filter is allowing these two colors only to be shown and blocking anything in the middle of it. So what is the in the middle of it? This is another graph that will show you what is in the middle of that. Here, the yellow parts, which I want you to focus on, is the artificial light. So something like the halogen lights, or something like the mercury lights. All of these are coming in these spectrums specific colors, with the exception, of course, the LED lights, because they screw everything now with LED lights, and LED lights emits a lot of emissions within these spectrums, so it's much harder to block them. That's why there is a filter for that, like the SV260 or the CLS filters, but they are less efficient than something like the 260, the SV260. However, it means that you are actually blocking only the spectrum of those materials of the artificial light, and also the moonlight material somewhere here, the moonlight wavelengths somewhere here, and you'll be able only to capture either those two wavelengths or something in between that uh, represent the galaxies, since galaxies are made of stars, and stars is like daylight here, which emits a lot of light within the light of the spectrum. And to see that, this is a representation of a new VIR cut filter. Basically, it allows from here to here, and this is actually the visible light. Anything below that 400 is ultraviolet wavelength, and anything above that number will be infrared wavelengths. So by choosing a filter like this one only, you can capture galaxies without any problems, or with some problems of the artificial light, which is like pollution. So a better choice will be ordering something like the SV260 that allows for the emissions here of the galaxies that's coming from there, without allowing these yellow lights that's coming from the artificial light. This is a technical part. I hope by now you grasp the filters in a better way, how to choose them, what is the available options in the market, and what is the bare minimum to buy from filters. And this will make, in the next episode, actually, we will gonna gather all of these together, how to collect them in your telescope, how to set up your telescope, and put everything together, ready for the next episode after that, which is using the ASI air and capturing a full night photography. Okay, thank you so much for watching. I will see you in the next episode.